Now I am teaching the first chapter of physics of class 10 of CBSE. The chapter is electricity. We everybody know about electricity, and we are introduced with electricity. We use electricity in our day-to-day life. Without electricity, we cannot go. That is why electricity is very important for us, and it's a very interesting thing, very interesting chapter also. So we have to read it carefully and understand it deeply. At first, you everybody know about electron, proton, neutron, and so isotopes, isomer, isobars. The idea of these things are also necessary to understand electricity. Electricity. We know that to read electricity, we have to know about current. And what is current? The current is the flow of electrons. Flow of electrons. That means to know what flow of electron, we have to know about electrons. What is electron? The electron is a component of an atom. Then what is atom? Atom is the smallest particle which takes part in chemical reaction. So atom is the smallest particle which takes part in chemical reaction. And electron is the component, one of the components of an atom. Electron is one of the components of an atom. That means in an atom, if this is an atom, this is the nucleus, the center of the atom. This is nucleus, and here proton and neutron are present. Proton and neutron. Proton plus neutron. Proton is positive charged particle and neutron is neutral. That means neutron has no charge. It's neutral. And proton is positive charged particle. And these are the cells in which electrons move. The number of cells started from K, L, M, and etc. The first cell is K, second is L, third is M, fourth is N. The capacity of carrying electrons of the cells are like this. The formula is 2 n square. N equals to the number of cells. That is the number of electrons in K cell. That is the value of K is 1. That is why 2 into 1 square equals 2 into 1 equals 2. The maximum capacity of bearing electron in cell K is 2. That is 2 n square. N is here 1. In the second cell, 2 into 2 square. That is 8. And so on. The maximum capacity. The maximum capacity of bearing electrons in a cell is the formula 2n square, where n is the number of cells. This is the structure of an atom. I think you understand it. Now, we are reading about charge. Actually, current, we know that there are two types of charges, negative and positive. So, how a charge is produced? How a charge is produced? What is charge? Charge are of two types, positive and negative. How this charge produced? When an element you know, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, aluminium, magnesium, and so on. Charge. What is charge? If an element either takes electron or discharge electron, the charge is produced. How? Sodium. The symbol of sodium is sodium Na, and it's a metal, and its atomic number is 11. We know it. And the electronic configuration of sodium is 281. 11. 11 is 281. The number of electrons in the first cell 2, second cell 8, and third cell 1. That is the outermost cell. And the number of electrons in the outermost cell is called the valence. Then we know that, or if you don't know, then I inform you that the metallic characters or metals, metallic elements, the elements which have the character of a metal, always lose electrons. That means here sodium, the number of electrons of the outermost cell is 1. That is why sodium can easily lose an electron, because it is less than 4. That if sodium lose an electron, that is minus E, then a plus charge is produced on sodium. Similarly, chlorine. Chlorine, the symbol of chlorine is Cl. It is a non-metallic element. Its atomic number is 70, and its electronic configuration is like this. The outermost cell has 7 electrons. That is why it can easily take an electron. And chlorine, when takes an electron like this, a negative charge is produced on it, like Cl minus. This is the positive charge, this is the negative charge. And now you understand how charge is produced. And what is the value of one positive charge? That means one charge of a proton equals to 1.6 into 10 to the power minus 19 coulomb. Minus 19 C coulomb. C for coulomb. And charge of a electron equals to minus 1.6 into 10 to the power minus 19 coulomb. And electricity is produced when electron flow. When electron flow through a conductor. That means you know about the atom. electron, proton and charge. Now flow of electron is called current. Current generally it is denoted by I. This is the symbol of current, and its current, we know that current is the flow of electron or charge. That means I equals to charge by time. The rate of flow of charge. Rate of flow of charge is called current. Rate of flow of charge. Here total charge is Q and total time is T. Then I equals to Q by T. We know that the amount of charge is very negligible. Its value is 1.6 into 10 to the power minus 19. That is why it is very difficult to catch a single charge. But we can easily count the total charge. That is Q. If n number of electrons are flown, n into E, then total charge equals to n into E. E means electron and n means the number of electrons. That is why I equals to n by T. Or we can write in this way, by T. This is the positive charge, 1.6 into 10 to the power minus 19. That is what, and it is the SI unit of current is ampere. That 1 ampere equals to 1 coulomb by 1 second. Okay, now we are reading about potential and potential difference. What is potential? Potential. We know that to bring something, we have to work something. Here, potential defined as the amount of work done or required energy to bring a positive charge from infinity to a point is called the potential at that point. The amount of work done or required energy to bring a positive charge from infinity to a point is called the potential at that point. If this is a conductor and it's a point A, from infinity this conductor is coming from infinite distance, then one positive charge to bring up to a positive charge is called potential at A, and it is denoted by VA. Potential at A is denoted by VA. If the point B is another point on the conductor, but we generally notice that B has long distance than A. With A is nearer to infinity, B is B has some more distance than A. And if the potentiality at B is BB, that means to bring a positive charge up to B, the energy spent or work done is BB. And for point A, potentiality or potential is VA. Then the potential difference is equals to VB minus VA. Like this. Only the difference we take here, not the sign. That is why I put this sign. This sign means on the difference, not positive or negative. Okay, this is the potential and potential difference. Now we read about Ohm's law. Ohm's law. Ohm's law. What is Ohm's law? Till now, we know what is current, what is conductor, what is time, what is potential. Ohm's law gives us a relationship between potential difference and current. According to Ohm's law, the electric current flowing through a metallic conductor is directly proportional to potential difference across its end. That means conductor X. If the physical conditions like temperature, etc. are same. That means if the temperature is not changed, the electric current flowing through a metallic conductor is directly proportional to potential difference across its ends. That is Ohm's law. That is V where I. We know that V is the potential difference and I is the current. If we withdraw this sign, where is the sign, a proportional sign, then we have to put a constant, and this constant here is R. That is V equals to IR. R is the constant. And this constant here is taken as resistance. this constant, this R, is called resistance. That is R equals to V by I. Potential difference by current. The SI unit of R is ohm. Unit of R is ohm. The sign of ohm is like this. That is 1 ohm equals to 1 volt by 1 ampere. This is the Ohm's law. If we draw a graph for Ohm's law like this, this is the current and this is the potential difference. Then we will get a curve like this. The angle is 45 degrees. These are the points. This is called Ohm's law or Ohmic graph. Now, this is resistance and the conductance. Conductance is the reciprocal of resistance, that is 1 by R. The conductance equals 1 by resistance. And we have to know also about resistance. What is resistance? Resistance is nothing but a hindrance or obstacle through the conductor when current is passed through it. When current is passed through a conductor also apply some hindrance or obstacles. This is called resistance. And 1 by R is called, or 1 by resistance, or the reciprocal of resistance is called the conductance. Now, some points on which resistance is dependent. And how resistance reacts with these things, like resistance. If this is a conductor, think this is a conductor or wire. It's a conductor. Its length is L, and this is the cross section, area of cross section. It is area of cross section, and it is denoted by A, area of cross section. L and A. We know that when water flows through a pipe, if the pipe is thick, that means the area of cross section is large, then water can flow very smoothly, and large amount of water we can get. In the same way, if the conductor is thick, then the obstacle resistance is decreased, negligible sometimes, and length, if the length is long, the resistance is also big, like R versus L. Resistance is directly proportional to the length of a conductor, and R is inversely proportional to the area of cross section. More the area of cross section, less the resistance. More the length of the conductor, more the resistance. If we write together, then we can write it like this: L by A, and this is rho into L by A. This is called rho, R-H-O. This sign, it's an Roman alphabet is called rho, and here it expresses resistivity. Rho equals to constant, and here it is resistivity. Resistivity, and 1 by rho equals to conductivity. For numericals, this formula will be used. Now we read about the combination of resistors. Combination of resistors. There are two types of combination of resistors. One is series and second is parallel. Series combination and parallel combinations. So series combinations, where resistors are connected in this way. This is called, this is R1, R2, R3. These are the resistors. If the value of R1, R2, 3, if R1 equals to R2 equals to R3, then the resultant resistance, Rs, S for series, equals to R1 plus R2 plus R3. Okay. And for parallel connection, when the resistors are connected in this way, then the resultant resistance one by Rp, P for parallel, 1 by R1 plus 1 by R2 plus 1 by R3. If R1 equals to R2 equals to R3, equals to R, then 1 by Rp equals to 1 by R plus 1 by R plus 1 by R equals to 3 by R. Therefore, Rp equals to R by 3. That means in parallel connection, the resultant resistance will be less than that of the original resistance. Okay? It is also very important to know that in series connection, the amount of current is equal, but the voltage is not equal. For every resistors, the voltage drop is different. Like if the resistors are for series connection, if voltage are V1, V2 and V3, but current is I current is passes through all the resistors, but the voltage V1, V2 and V3. Here V1 less than V2 less than V3. That according by applying Ohm's law, V equals to IR. Therefore, V1 equals to IR1, V2 equals to IR2, V3 equals to IR3. But total voltage V equals to V1 plus V2 plus V3. Therefore, if we put the value of this IR1 plus IR2 plus IR3, if we common I, then R1 plus R2 plus R3, and V equals to IR. I cancel. R equals to R1 plus R2 plus R3 2 for series connection. And for parallel connection, we can also prove it. For parallel connection, parallel connection, for parallel connection, we have to know that the amount of current is different here, but voltage is same. That means here V1, V, here V, here V, and current is I1, I2, I3. Current is different, I1, I2, I3 for the resistors R1, R2, R3 respectively, but the voltage is same for all the resistors. And this is the benefit of parallel connection. Therefore, I equals to total current I1 plus I2 plus I3. According to Ohm's law, V equals to IR. So V is here same I. Therefore, I equals to V by R. I1 equals to V by R1. I2 equals to V by R2. I3 equals to V by R3. If we add I1 plus I2 plus R3, I equals to I1 plus I2 plus I3, then V by R1, V by I2, R2, V by R3. We can take common V, 1 by R1 plus 1 by R2 plus 1 by R3. And the value of I is V by R, total resistance. Therefore, 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Here R, we can change R equals to RP. That is resistance for parallel connection. In this way, we can prove 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. If the number of resistors will be increased, then 1 by R1, 1 by R2, 1 by R3, and the number of resistance increase, then these are also the resultant resistance will be 1 by R1 plus 1 by R2 plus 1 by R3 and dot 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 dot.